Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 1-3 homework solutions on modeling with linear functions. For this problem, they want us to use this graph here to write an equation of a line and interpret the slope. So we have this gasoline tank sort of graph going on, and the y-axis is fuel in gallons, x-axis is distance in miles. Now, to get the equation of a line, we need the slope and either a point or a y-intercept. Let's get the slope first. So we're going down 3 and over 90 from the starting point here. So we can write negative 3 over 90. And the y-intercept, actually, they gave that to us. If we look closely here, let's see, these grid lines are going by 2's. So this is going to be a 12 up here. So we'll use 12 for our b value. Since we have the slope and the y-intercept, we're going to use y equals mx plus b, that form of a line, slope-intercept. So I can write y equals, now let me just reduce this slope to negative 1/30 x, and then plus 12. Now in terms of the slope that they want us to interpret, so the top unit here is gallons, the bottom unit is miles. So this is gallons per mile that this is changing, and it looks like it's going down. So it looks like that we're going down by, our fuel is decreasing by 1/30 of a gallon for every mile driven. Right, for this problem, they want us to use the graph to write an equation of a line and interpret the slope. So to get our line equation, we're going to want to get our slope, and if we can get it, the y-intercept, otherwise we'll use a regular point. So for the slope on this one, they gave us these nice little convenient arrows. We're going up 100 and right 2, so rise over run. We've got 100 over 2, which we could reduce to 50, but we'll just do that later on. Now for the y-intercept, the b value, our grid lines here are going by 50s, it looks like. So if I'm 50 down from 150, that looks like 100 right there. So that's my b value, 100. So using then y equals mx plus b, I can write y equals 50x plus 100. And now to interpret the slope here, this 50, the y units are dollars, the x units are weeks. So this is $100 for 2 weeks or $50 for 1 week. So if this is a savings account, that must mean that our account balance is going up by $50 per week. So for this problem, you are considering buying a phone from one of 2 cell phone carriers, and we have a table down here showing us total costs of the phone and service for a different number of months for just carrier A. Total cost of the phone for carrier B is actually represented by this helpful y equals 55x plus 300 equation. We want to know who charges less per month and after how many months of service are the total costs the same. So in order to do both parts of this problem, I'm actually going to need to take this table data and convert it into the equation of a line. I just need to find the slope of this table data to compare the relative, what did they want us to compare? Who charges less per month? The per month is just the slope. But again, if I want to be able to figure out when their months cost the same, I need the equation of a line for that second, or for this A carrier. So let me start by getting the slope in this table. So I'm just going to use y2 minus y1 over x2 minus x1. And for my y values, for my points, since it looks like we're going up by 150 each time by the same amount for the same change in x, I'm just going to use the first 2 points. So 650 minus 500 over 6 minus 3. So that's 150 over 3. Which reduces to 50. So that's $50 a month, and we can compare that in a moment. But now before we do that, let me just put this in the equation of a line. So I'm actually going to use y equals mx plus b, and you might be wondering, well, how am I going to do that? I don't have the y-intercept for this. I don't have the 0 value, but I think I can figure out what it is. These things, for every 3 x's you go up, you're going up by 150 for the y's. So if I go back 3 to 0, then I just subtract 150, and that would bring me to 350. So then I can write my equation for the A carrier here of 50x for the slope, and then plus 350. So our slope is 50 for carrier A. For carrier B, we have 55. That's the slope in this 55x plus 300. 55 is greater than 50. So that means that carrier A is going to be the one that charges less. Okay, so when do they charge the same amount? So let me take my first equation that they gave me, this 55x plus 300, and I'm just going to replace the y in there with 50x plus 350. If I want to find out where the y values are the same, where the costs are the same, I basically just set these two lines equal to each other with my substitution method. So I've got 50x plus 350 equals 55x plus 300. And then I can do a little subtraction dance to get x by itself. Let me start by moving 300 over to the left. That'll give me 350 minus 300, or 50. And if I subtract 50x to the right side, that's 5x over there. So then x equals 10, meaning after 10 months, these carriers have the same cost. On this one, we want to determine whether the data in this table show a linear relationship. And if they do, write an equation of the line of best fit, and then figure out y when x equals 15 and explain what that actually means in the context of the problem. All right, so I'm going to do all this on Desmos. Let me go there now. So on Desmos, I'm going to hit my little plus and get a table, and then put my x and y's in there. So we got 1, 6, 11, 13, and 16. And going back up, we've got 6, 27, 27. And then 50, 56, and 70. Now I'm going to hit this little zoom fit button, and let me just move everything over so I can see it better. Zoom fit, and then hit this linear regression, add regression button. And this is clearly linear. So now I want to write my equation here. This is y equals 4.2 and some change plus 1.7 and some change. I'll just round it off a little bit here. So we've got the picture, definitely linear. There's my equation, and I'll call this f of x. You can call it y or f of x, doesn't matter. Now to plug 15 into this, I'm going to be a little crafty. Going back to Desmos, I'm going to click this little button that exports my equation down to the next line here, and I'm going to change that y to an f of x so I can plug anything in that I want. Arrowing down to the next entry field, I just write in f of 15, and I get back the value of 65.65. Now they want us to interpret what this actually means. So the x values are minutes spent walking, the y values are calories burned. So if I plug in 15 and get this back, that means that after 15 minutes of walking, I've burned roughly 66 calories. On this one, they want us to use technology to get an equation of the line of best fit for this data, and then identify and interpret our correlation coefficient, that R value. So in order to do this, I need to actually kind of read these points off and plug them into Desmos and go from there. So let me get Desmos out. All right, here we go with Desmos. Let me hit the plus to get a table. And now I'm going to just put each point in. So from left to right, we've got the point 1, comma 1, and then we've got, let's see, that looks like 2, comma 3, and then 3, comma 2, 4, comma 3, and also 4, comma 5, so not a function, fails the vertical line test. And then we have nothing at 5, we've got 6, and that's going to be a 3 for the output, and then 6 again, and then this point here is at 4. Okay, so that looks like a pretty good representation. Let me zoom fit that just to get a little closer. Yep, looks like the same thing. And then hitting our regression button, there it is. So if we scroll down here, we have y equals 0.42x plus 1.44. So we'll put that in there. And now for the R value, going back to Desmos, it looks like that's 0.61 and some change. Now, in terms of interpreting that, that's a positive correlation for sure. It's bigger than 50, bigger than 0.5. So it's, I mean, It's kind of a gray area. It's definitely not strong, but it's not really weak either. It's not like below 50. So I'm going to call this moderate positive correlation. It's my story and I'm sticking to it. On this problem, they want us to find the equation of the line of best fit for this scatter plot here, and then interpret the correlation coefficient. So we're going to go to Desmos and punch in these points manually. So on Desmos, I hit the little plus to get my table. And let me put in my points one at a time. So going from left to right, we've got 1, 5. And let's see, next we got 2, well, I guess I'll just go down. 2, 4, and then 2, 3, and then what's next? 3, 3, and 3, 2, 4, 1, and 5, 1. All right, so let me do a little zoom fit and hit my regression button. Linear regression looks good. Not a great correlation there, but we'll take it. So our equation is this negative 1.039 and some change. I'll just round it off to maybe 3 decimals, plus 5.684. So there we go. 2 decimals then. That'll work. And then for my R value, we've got about negative 0.93. So in terms of interpreting this, anything past 0.9 or negative 0.9 is going to be a strong correlation. And then this is a negative one, so negative strong correlation, strong negative correlation. For this one, which is an honors problem, the table is showing some femur lengths in centimeters and heights of several people. Do these data suggest a linear relationship? We want to know. And if so, get the equation of the line of best fit and estimate the height of a person whose femur is 35 centimeters long. All right, well, I'm going to plug this all into Desmos to see what it looks like. So here we go, Desmos. Let me hit the plus to get my table and start putting these values in. So I'll do all the x values first. We've got 40, 45, 32, 50, 37, 41, 30, 34, 47, and 45. And then scrolling back up, I want to do my y values. So 170, 183, 151, 195, 162, 174, 141. I could get a job doing this. 151, 185, and then 182. So what does this all look like? Well, I can't see it on my graph now, but if I click this little magnifying glass, the zoom fit, now I can see it. And that does look pretty linear to me, but let me go back up here and just draw this little regression line through it. There we go. So definitely linear, and the equation of our line of best fit is about 2.603x plus 64.997, or you can round it off a little more if you like. Doesn't matter too much. I'd say 2 or 3 decimals is good. Now, if we want to estimate the height of a person whose femur is 35 centimeters long, I essentially want to plug 35 into this thing that I just wrote. To get the most accurate answer possible, I'm going to go back to Desmos, and I'm going to export, using this little button here, this full thing that I just got. So that bumps it down to this line here. I'm going to change this y to an f of x so that I can plug in anything I want. And I wanted to plug in 35, so let me do f of 35. And that comes out to about 156 and change. So that is the rough height of a person with a 35 centimeter long femur. Good to know. For this problem, which is fairly pertinent to students now, the data pairs represent the average annual tuition and fees, which are going to be Y in dollars for some private nonprofit colleges and universities in the U.S. X years after the 2012-2013 academic year. Awesome. So that means like this first one, 0, 31,890, means that the tuition in, let's see, this would be the 2012-2013 because it's 0 years after that. That was our tuition there. So using technology, we want to find an equation of line of best fit for all of this, interpret the slope and the y-intercept, and then estimate the tuition in 2022, 2023. All right, so we're going to go to Desmos and plug all of these points in there to see what it looks like. So in Desmos, I'm going to hit the plus, get my table, and let me just put in that first point. We've got 0 and 31,890. And I'm going to put in the other points off camera just because it's annoying to tab back and forth between that. All right, we're back. I've entered all that stuff in my table. I'm going to click the magnifying glass to get a little zoom fit and tell me where all those are. And then let me hit my regression button. So there we are. The equation, it looks like, is 723.21. You can just round it off to 2 decimals, plus 31,867.5. So here's the graph that I just did, and here's the equation I just came up with. So what does this all mean? The slope here of 723.21 is telling us how much the dollar amount is going up per year. So we're increasing $723.21 per year for tuition. And then this y-intercept here is telling us what the starting value was in year 0. So that would have been in the 2012-2013 academic year. That's what our tuition was, $31,867.50. The last thing they want us to do is estimate the tuition in the 2022 year. So that's 10 years after year 0. So we're basically doing f of 10, which let me go back to Desmos and do that. So what I'm going to do here is take this equation I got and export it with this little button down to the line below. Let me turn that y into an f of x. And then let me just do f of 10. And that gives us $39,099.64. So that's what you're paying 10 years after this whole process started.